Welcome to July 20th LeetCode Challenge Shuffle an Array. Given an integer array nums, design an algorithm to randomly shuffle the array. All permutations of the array should be equally likely as a result of shuffling. Implement the solution class. Solution takes in the parameter int array nums, initializes the object with the integer of array nums. You have a reset function to reset the array to original configuration and returns it. And then you have a shuffle function which returns the random shuffling of the array. So basically, pretty much you invoke a solution that you call shuffle, which shuffles your array, and then reset it, and then resets it to the original array, and then shuffle it again, and then makes a randomly new shuffled array. That's pretty much it. We are developing a class here, and there is a hint to expect the original array to shuffle else the case fails. Alright. Our constraints. Each number of all elements are unique, so that's good. And most the calls in total. Okay. So let's actually try to basically do a linear scan, so via brute force. That's pretty much the first thing that kind of pops to mind, but there's another solution after this I want to show. So let's see. Self.array is assigned to be nums, and then we have self.original. We have the array called nums, and then we're gonna have the original array that we're gonna save it. So when it resets, so we'll call it original. Should I call it original? Or copy. You call it copy. Copy of the original. And that's going to be the list of nums. List of nums. Ideally, we could also do, yeah, let's just leave it the way it is. Then what do you want to do now? So you want to reset the array. We're going to have to do self.array would be assigned to the original list of self.copy of the original array. And then what we want to do is return, nope, we want the self.copy of the original array. What we want to do is make that actually a list. And then we want to just make this. So we assign the self.copy, the copy of itself, the original, to array, and then we return. We are going to return actually the original array. So return self.array. Alright, these two look somewhat intuitive for our init function or reset function. Now it's a little bit of a tricky question here. So how do you want to shuffle it? So we're going to do a linear scan. So let's see. We're going to need a variable to hold the list of the self array. Let's call it it's got to be a second array, so we're going to call it lists. Yeah, I'll call it list. List of the self.array. And what we're going to do is do a for loop. So we're going to iterate through each index for I in range of length of list. So we're going to do a linear scan here. We're going to have remove the index. So we're going to call this remove. And then what we're going to do is going to randomly use a random function. So random range of the length of list. And then we're going to just update the self.array index I to the new list.pop of the remove function, and then we're going to return self.array. It's pretty much we're doing a for loop here, going through each index of the length of the list of the self array. Remove any element that we're gonna do a random function to remove an element here. The index to remove, I should say. And then what we do is we pop it off, and then the number that's popped will be the new index. Let's see. So it looks good. It's a bit slow. I mean, it's time complexity is big O of n squared. It's quadratic time complexity because we're using a pop function here, which runs linear time, and also we have a removal type of let's see, which runs linear time, and then n linear time list removal occurs, which occurs at quadratic time. Space complexity is obviously big O of n because we store everything inside our array. Alright, so that's big O of n squared time, but if we use something called a Fisher-Yates algorithm, we can actually simplify it to the time complexity to big O of n. So I'll just quickly go over it. So basically, you want to cycle through the array using a for loop as well. However, you're gonna create, each iteration, we're gonna generate a random integer between the current index and the last index of the array, so that we can just swap the element as we go through the for loop. So let's see. This is the same. This is the same. So let's erase this. This is basically the Fisher-Yates algorithm, which means that we're randomly assigning a new integer, a new index, a new number to each index as we cycle through a for loop. So we still have the same. We don't need to make another list, by the way. We just use the same list. So self.array. And then what we want to do is the index to be, instead of removing it and popping it, I'm going to swap it. So I'm going to call it swap. And I'm going to use the same random dot ran range. It's actually quite similar to the brute force, actually. And length of the self.array. And then what we want to do is reassign some variable self.array at index I. Is going to be equal, and then we also want to rearrange self.array at index swapped, and that's going to be reassigned to self.array at the swap index, and we're going to swap the array at swap index with arrays at I, self.array at I. So basically what we do is we go through the for loop for each index of the self array. We're going to assign a random swap variable according to the index. And then we just basically swap array index I with array index swapped. And then array index swap with array index I. And then we return our self array. This should be big O of n because the Fisher-Yates algorithm runs at linear time, generating a random integer while swapping two values. Let's see, what am I doing here? Random. Comma there. Sorry about that, guys. Hopefully this works. Looks similar. Yes, accepted. Awesome. So yeah, both time complexity and space complexity is big O of n because the for loop ranging through it is swapping automatically as we go along, so there's no need to store anything additional. And yeah, that's it. It's kind of annoying, but the Fisher-Yates algorithm does, if you're familiar with it, does make things a little bit more simple. And yeah, have a great day, guys.